Welcome to another day of working on a large hexapod. Today, finished a lot of the body work that I've been working on recently and is detailed in the website. And here's just a quick video record of what was done to go along with the photos. One of the first things that was done is down here was adding the new control panel, master control. This is a master key switch, basically allows me to control the on and off. Then there's a motor and computer switch along with the charger for the new battery system. Behind this is where the fuses for the motor controllers come, and the power is distributed, the positive and the negative wires go through there. So that gives us some all the controls that we need for that. The next section, when we go around, this was another new addition. This was a laser cut piece of plastic used as the backing, and this basically gives me a mounting surface and a nice clean setup here where you can see the relays for the motor and the computer system. Here is the distribution power for the 12-volt power as it comes in from the battery and then is distributed as needed. So then to these terminal boards down here, which help basically control allow the switches to turn the relays on and off, which supply power then to their various systems. We got a jack down here for lighting. That's interior lighting. And then also a series of jacks right here, connectors for everything from the voltmeter to the switch from the computer, the motor, power to an LED, and also from the master key. So just a lot of cleanup from the earlier version of this, if you remember. Now, I originally planned on putting the shunt, which is going to be used to measure the current draw, right there, but I didn't take it into account was the panel, the cover panel over here interfered with this because this thing was too tall. The shunt was too tall. So it's been relocated to on the other side of the panel. And just another thing that you don't think about until after you actually go and start test fitting things together. Coming further around, we now come to the computer side distribution system. And these are all the fuses for the computers that are being used in the system right now. And also this will be also anything that basically requires 5 volts. So there's 7 filled in right now for the 6 leg controllers and the 1 master computer, which is this one right here. Coming around further again, we now see the entrance into the actual battery level area. There's the shunt way in the back in the upper right-hand corner. There's this red connection right here. This is a high current connector for the battery. This is where the battery connects in. The little box back here is the 12 volt to 5 volt converter that's being used to provide the computer power. A lot more space down here now that I don't have a lead acid battery in here. It's a little messier in here. I still need to add some more wire wraps and tie things down a little bit better too, but not too bad. And the last side, the 6th side of the battery level, is right here, and this is a Lascar Electronics panel meter, a programmable panel meter that's currently programmed for the lithium battery that I've now using. Speaking of which, here is the lithium battery. This is was basically a kit setup where I could buy these plastic end caps that you can see, the orange and black, that slide over the ends of the standard 18650 lithium cell. They then you can bolt on these small pieces of metal in any direction you want, so that you can configure this battery to be whatever voltage and amount of amp hours that you need. Now, the only problem with it is it looks a little messy right now because normally it'd be enclosed inside black shrink wrap. But I ran into a battery issue that discovered that right here, this is the battery management system, which makes sure the battery is not overly charged or you over discharge it, and basically protects this battery from becoming a doorstop. Anyway, the battery management system was not working properly, and I contacted the folks, and they're going to send me a new one just as soon as they come in. Right now, they're all back ordered due to a lot of supply issues. So, but nice battery, much smaller, much lighter. I think it's going to be a good addition to the robot. Moving up higher to the motor level, this is where each of the legs themselves physically attach. The motor controllers are located. Each leg has got 3 motor controllers, so there's 18 total. These bolt in. There's 2 connections down below for the where the leg connects in. This piece of plastic here basically is a guide, so it slides in and lines it up to the right spot. And there's also connections up here at the top too that come in through the computer deck. Physically, what you have is the large opening here is where the coxswain motor slides inside to this area. Above that, this is the sensor connectors that are used, and I've got some spares available right there as I add additional sensors if necessary in the future. And here are the power connectors to the motors on the leg itself. Here's the computer deck. A few changes here. First thing is I moved the master computer, which originally was just kind of sitting up here loose. It's now bolted down. Not sure this is going to be the final location, but moved it to here, and so it's nice and steady. Moved it so that I could drill a hole into this spot and put an eye bolt right there. And this connection basically is for the safety cable that goes to a rafter. Let's see, if we go straight up, there's the hook, and there's the pulley system, and that's basically what used to keep this thing from falling over when I'm testing, which has happened. Next up here, a change was that I never liked the way the RoboPi could be mounted. Unfortunately, there's only 2 holes in the circuit board for mounting, and they're diagonal to each other, so that if you're pushing in connectors on one side, and it would rock the circuit board and was causing the nylon screws, which you use because of the close proximity to everything, can use metal screws. Those nylon screws would work their way out and all become loose. So what the answer came up with was to cut a frame out of plastic using a laser that goes exactly around the entire board. That frame is glued onto the plastic back right here. And then there's this piece of plastic held in by 2 screws, and there's 2 more down below that, yeah, it's hard to see. Oh, you can see the shiny screws, and that's about it. Looking at the floor of the workshop, that's where all the legs are hiding. So there they are laying down here, taking up a lot of tripping area. And really didn't do too much change on these guys. Still, you've got all the, oops, let's get the camera on the right spot. Here's all the sensors, here's the power connectors. Everything's been kind of wrapped in some plastic loom to make it look a little bit nicer. Here are the magnetic encoders. This is for the coxswain, not the coxswain, excuse me. This is for the femur and tibia. And coming down to the ends, the new little ball or round shape here with the rubber protective cover. Underneath here is the new flexible sensor. It's a flexible potentiometer under there that basically senses whether or not this is touching the ground or not. And it can sense from quite a wide range of angles that the foot could potentially touch the ground at. Each one of them's got one. And so next step is to go ahead and reattach all these guys.